not pointed, the straight up and down glass is a beaker. The one that's triangular is called an Erlenmeyer flask. All right, now somebody can put in, after a little stir, you can put in 5 drops of potassium manganese. Ultimately, you guys are gonna have to be in the center so that the other guys can see. 5 drops. Then stir. And then on your lab, you're gonna record the first color. That's the initial color. Can you slide your Erlenmeyer flask to the side? It's right in front of the camera. Or whenever you chance. 5 drops. Why does it take so long? It's not, it doesn't have to be exact. If you squirt a little extra, it's not the end of the world. All right, so you're recording your first color. It should be purple, right? Now you're gonna unwrap your lollipop and you're gonna stir with your lollipop. You can take your stir stick out and just lay it on the edge of the top lab table up top there. Up top, so nobody, it's not poisonous, but still don't need to contaminate the surface. All right, give it a good stir. And what's happening is sucrose is going to react with this substance and you're going to see a different color. Then you're going to record the second color, then the third color, and then the fourth color. You're seeing the sticker. So what was the second color? You guys already passed it. Blue was the second color. They already passed it. And then you're going to keep stirring and record the third color. Yep, blue and then green. And then it's going to take another minute to see the fourth color. So what you're seeing is the different oxidation or different charges of the manganese that are possible. If you want to switch up, somebody else wants to stir. Keep going, takes about a minute up there. Oh, yeah, keep going, keep going. I'll leave these right here if you want to take them before you go.
Czyryca.
Yeah.
Does part 2 have to be here?
Does what?
Part 2.
Yep. Yes, you do, because you're not doing this tomorrow. All right, keep going, keep going. Are your fingers tired? All right, I see one. It's turning completely the right color. You guys need to do a little bit more. All right, you guys are good. You probably reached your end point there. You can toss your lollipop in the trash. You're done. Stir vigorously. All right. Maybe we'll call it a day and just put this down. This was the orange color that it was supposed to turn. Maybe the number of drops of permanganate did matter. All right, you're good. So it should be orange. So we have 4 colors. We should have purple. Right there. Purple, blue, green, and orange are the 4 colors that this changed. All right, you can stop sharing, Matt. Share. We're gonna do some algebra. You guys like algebra? Better than geometry? Most people like algebra better than geometry. All right, so we have purple, blue. So initial color, purple. That substance is potassium permanganate. So there's a permanganate ion in there. Okay, so the charge on manganese is what we're going to calculate. Well, this is a polyatomic ion. So the whole thing has a charge of -1. oops, -1, whoops, -1. Because that's what it says right there, -1. And that's what we're looking at when we look at the charges, that when we write the formulas, we're looking at the fact that there's only one negative, not four negatives. That's the total. So that's not ionic, right? Because it has a charge. We're missing the cation. The cation was in the original substance, potassium permanganate. Show the work. Okay, we have 4 oxygen. What's the charge on oxygen? Anybody remember? It's in group 16, -2. Oxygen's always -2. Oxygen itself is -2. And so what we're going to solve for is the Mn. I just put X because you guys are used to using X instead of using Mn. You could have used M, I guess. And now solve for X, and that'll give us the charge on manganese. You can tell me a charge on manganese here. 7 plus 7. So when we see Mn Roman numeral 7, that substance is probably going to be purple. More than probably, it will be purple, because we just witnessed that the MnO4 negative is purple. That's what made that initial substance purple. Second color, I'll keep that for a second, was blue. This substance is called manganese. It has a -2 charge. The whole thing is equal to -2, is what that means. There are 4 oxygen. Each oxygen is -2, always. So we need to find out what the charge on manganese is. It's going to be different because now it's all equal to -2. What's the charge? 6. Putting a plus because it's a charge. So that would be the Mn6 ion. Then we had green, and that's called hypomanganate. It has a total charge of -3. My charge is in the spot. Total -3. It equals, we have 4 oxygen, each with a -2 charge, and we're solving for Mn. Now what's the charge? Anybody at home can do some algebra? X minus 8 equals -3. What's X?
5.
5, thank you. So X equals +5, so Mn equals +5 in this case. So when we have manganese 5 something and it dissolves, it's going to be green. And then lastly, orange. This substance you should be able to figure out the name of, because it's something that we probably had on an assessment or a handout before, because it has no charge. So no charge shown means what? It's neutral. It's neutral. So the whole thing equals 0. And we have a metal and a non-metal. So what do we have when we have a metal and a non-metal? An ionic compound. Because there's no charge shown, which means not an ion. It's the whole package. We've got the positive with the negative there. So solve for 0, just like you would, and you should be able to write the name. So you guys should be able to do this without actually doing algebra, because we've been doing it. The charge on O2 is -2. Then what's the charge on manganese have to be? What is it? Anybody at home? What's the charge on manganese? 4, right? We have 2 negatives, 2 -2s, 4 negatives, so we have to have 4 positives. We haven't been doing the algebra because it's always equal to 0. We've just been figuring it out. We can do the algebra. 2 times -2 equals X, so it's +4. What's the substance called? Manganese 4 oxide. That's what we've been doing, naming and writing formulas just like that. Charge on Mn is +4. So what was the point of this activity? What did you determine about the element manganese? What did this show us? It has different charges, and those different charges, the fact that that manganese is different is very evident to us here because each of them had a different color. They're a very different substance. So we determined that manganese has at least 4 different charges. Possible charges. And so what does that mean when we write the name? We need to tell the world what the charge is because it matters, because those 4 substances are actually very different substances. And all we've done is changed an electron. So you must show the Roman numeral. When writing the name. Everybody get this? You want 5 points, then you turn it in and you get 5 points. 10 points, I think I put 10 points on there for lab activity.